Hello and welcome to your video on measures of spread, which will focus on the standard deviation. So what I want you to do is to first take a look at this activity. So 5 different employees at Mulock Moccasins noted how many moccasins they sold over the past 7 days. So the numbers were placed in numerical order, not chronological order. So it doesn't mean that the first day he sold 13 and the last day he sold 17. So they're just put in numerical order. So I want you to think about who should be employee of the month and then justify your choice below. So the way the data works is all 7 days, Ariana sold 15 moccasins. And you can look, she had a mean of 15, a median of 15. Billy Bob sold 13 moccasins one day, 15 moccasins 5 days, and 17 moccasins one day. So that's the way the data reads. So take a minute, pause the video, decide who should be employee of the month and why. So pause the video and decide. Alright, so who did you think should be employee of the month? Well, your answers will vary. It depends on different people. Some people may say that Ariana should be employee of the month because she is most consistent. Some people might have said that Eldred should be employee of the month because he has the capability of selling more, but unfortunately, he also has days that he sells the least. So you can see here that Eldred has the least consistency. And you might have said Billy Bob or Kurt or Dolly for some other reasons, but what I want you to focus on is this consistency. This calculation here, STD-DEV, stands for standard deviation. And the standard deviation measures how spread out the data is. You see here Ariana's data is all 15, and that's why her standard deviation is equal to 0, because there is no spread. Billy Bob, most of the numbers are 15, but there's a little bit of difference in the numbers, so his standard deviation is higher. Kurt is very similar to Billy Bob, but here there's only 3 numbers that are exactly the same, whereas here there are 5 numbers that are exactly the same. So that puts his standard deviation a little bit higher. With Dolly, she also has 3 numbers that are the same, but the numbers that are not the same are further away than Kurt's. So that puts her standard deviation a little bit higher. And Eldred, you can see here none of his numbers are the same. He's got the biggest spread, least consistency. Least consistency means higher standard deviation. Now the only measure of spread you have learned thus far has been the range. The range takes the maximum number, which in this case is 17, and subtracts the minimum number, which is 13. So his range is, his range is 4. Kurt's range is also 4. So the range is one measure of spread, and it just takes the difference between the highest and the lowest value. But what the standard deviation does is that it takes into account all the numbers in between. And that's why Billy Bob has a lower standard deviation, even though they have the same range. Because between the maximum and the minimum, the numbers are more consistent for Billy Bob than they are for Kurt. So that's what that is what the standard deviation measures. It measures the spread. And I'm going to show you how to calculate the standard deviation. But before we do it, there's a few symbols that you need to remember or you need to know. So first of all, you should know already that X bar represents the mean. You should also know by now that N represents number of data. This one you should also know, the F stands for frequency. And here's the new one, S stands for standard deviation. This symbol here you have also seen before. That symbol right there stands for sum, which of course means to add up. Alright, so let's look at some of the symbols that you don't know. This here is the Greek letter called mu. And it also stands for the mean. The only difference is that X with the bar on top is the mean of a sample, and the mu stands for the mean of the population. So if you were using a sample, you would use X with the bar. If you were using a census, so collecting data from the entire population, you would use mu for mean. Little n stood for number of data. Capital N also stands for number of data. Once again, little n would be the number of data in the sample, and capital N would be the number of data in the population. So, little s is the standard deviation in a sample. This letter here is called sigma, and that is a lowercase sigma. This one here is also called sigma, but it's uppercase. So if you were using a sample, you would use S for standard deviation. If you are using a census and getting data from the whole population, you would use sigma to represent your standard deviation. So those are all the symbols that you need to know to be able to follow the formula for standard deviation. So a deviation is the difference between an individual value in a set of data and the mean of the data. So if your data was equal to 5 and the mean was 7, then your deviation would be 2. Now they talk about the variance. You don't really need to know too much about the variance, and the definition of variance doesn't really make sense. It says the variance is the average squared deviation of each number from the mean of a data set, and the standard deviation is its square root. So the definition of variance and standard deviation is really just telling you how to do it. It really doesn't tell you what it means. So let me show you how to do it, and then we'll come back to that. So Billy Bob has a job laying down patio stones on weekends. He records how many he places on a sample of Saturdays and Sundays. So what we're going to do is we're going to write this out for Saturday. We're going to write down all the data. So 41, 41, 32, 38, 38, and 38. So those are all your X values. The first thing you need to do is calculate the mean. So down here, if we add them all up and divide by 6, we get 38. The next thing you have to do is to calculate the deviation, which is the piece of data subtract the mean. So you take each piece of data and subtract the mean. So 41 minus 38, etc. 41 minus 38, 32 minus 38, 38 minus 38, same here, same here. The next step is to square all of those values. So 3 squared is 9, 3 squared is 9, negative 6 squared is 36, and 0 squared is 0. The next step is to add all of these values up. So here you're going to label this as the sum. If you were to add all of these values up, you get 54. The next step is to divide by n minus 1. So in this case, n is equal to 6. So in this case, we're going to divide 54 by 5. And when you divide 54 by 5, you get 10.8. Alright, it brings us to our last step. And in our last step, what we are going to do is take the square root. So it's going to be the square root of 10.8, which is 3.29. Always round to 2 decimal places. Okay, so take a second and try doing the same work for Sunday. So just to remind you, the blue is the first step, so writing down the data values. The green is the second step, which is figuring out the mean. The red is the third step, which is finding the deviation of each, so subtracting each data value from the, or subtracting the mean from each data value. Squaring each of those deviations is the fourth step, right here. Adding them all up is the fifth step. Dividing by n minus 1 is the sixth step. And then square rooting your answer is the seventh step. So press pause on the video, try doing this for Sunday, and then press play on the video again to check your answer. Press pause now, please. Okay, welcome back. So hopefully all of the data values you wrote down first. You got a mean of 41. When you subtracted each of these values minus the mean, that's what you got in this column, which is your deviation, x minus x bar. Squared each of those numbers. Added each of those numbers up. Divided by n minus 1, which is dividing by 5. And then taking the square root, rounding to 2 decimal places. So that is how you calculate the standard deviation. Make sure you label all of your work. When you get a question like this, you'll be given the table, but these headers and these labels here will not be provided. You will have to label those yourselves. So this concludes part 1 of the video. Please make sure that you watch part 2 of the video as well.